Well, Northwestern Europe again shrinked to only the Dutch situation. Um, Now we are going to look into the soil-grown crops. Um, Again, yes. Okay. When we look to the soil and about soil fertility, um, there are a lot of issues related to soil fertility. As you know, there's the structure, there's the nutrients which are there, organic matter. There is a lot of interaction between these things, and then on top of that, we do fertigation. We irrigate our crops depending on the soil, the buffer, the plants. Also, microorganisms very important in the soil. They need water. And then, of course, it has an effect on the availability. So it's quite complicated. And if you combine the two, one more thing. If we want to, well, take care of the environmental issues, then we do have a lot of parameters we have to deal with. They are all linked to each other. So altogether, it makes the situation really complicated. So when we talk about fertigation, well, that's quite a thing. Well, I'm not going to deal with all the details, of course, it's way too much. It took me days, but just showing you a slide which I took from a presentation of 1995, which I presented at a conference, showing that at that time we have 3,000 hectares of soil-grown greenhouse crops at that time, which was 30% of the total, mainly cut flowers like chrysanthemums, but also some vegetables. And the issue was that at that time we had a review of what is the water use, nutrient use, what is the actual consumption by the crop, so what is the excess? And the excess was, like here, we had on average over 600 kilos per hectare of nitrogen leached out from the soil, or not leached out, it was a surplus, which assumably was also leached out for a great part. So this was not a good situation, of course. Now we had to improve the whole situation on fertigation, and we looked into many different issues, like the water resources, the effect of water quality and salinity, irrigation, soil conditions. But the most important thing that we must focus on the reduction of the leaching. And so if you ask a farmer, what is for him the driving, what drives him to decide on fertigation, then it's just, yeah, well, I want to irrigate amount just to feed my crop, just enough to maximize yield. That's of course important, but on top of that, I give some extra because I don't want to have some failures. I want to be sure that every plant in my farm has sufficient water, which means that you have a surplus. Also, we did some survey, and Carlos showed this morning what has been surveyed in Fertinova, and I think it's more or less the same outcome, that if you ask growers what is driving you to decide on irrigation, then here it says that, well, in the scale, green is negligible and red is very important. And you see that the red and orange part is mainly that it's based on experience. The irrigation is mainly based on experience. And also well, it sounds odd, but it has something to look at the color of the soil. That's also for a grower very important to decide to irrigate or not. And he looks at his crops. And the other things like tensiometers, soil moisture sensors, radiation sum, or the amount of drainage is of really less importance or even negligible. So quite some work to do. What did we do? Well, we started from the principle that growing in a soil, you can never reach the success we have with soil less, because it's an open system. You cannot make a closed water cycle. Although in Holland we can collect drainage water, we can reuse the drainage water, but still we can consider it as an open system. So what we have to do is to control the input. Less input just to minimize the leach out. So reduction of the water flow. And we decided to have a pragmatic approach, like cooperation with the growers and advisors, and step by step coming to an improvement. So, one step, two steps. Yeah, well, we of course, it's important when you look at the whole thing, that it's not only optimization of the irrigation, you have to take the whole cropping system into account. For instance, if you have a bad irrigation system, then the first step is improve the irrigation system. Or if you have a very heterogeneous soil, well, do soil improvement. But for this, now I go just on this part, which is about the decision support systems for precision irrigation. So advise when and how much to irrigate and how much to fertigate, and also monitor the soil conditions and the climate. There are two systems I want to show this morning. One is the use of soil moisture sensors and which activate the irrigation. And I have, well, maybe you know all these systems, just that you have sensors in the soil which give you a signal about the soil moisture content, and based on the soil moisture content you irrigate. And just an example showing this was a comparison of irrigating based on this soil moisture sensor and compared to the grower's decision. The light blue line is the grower's decision irrigation, and the dark blue is the soil moisture content activating the irrigation. Well, what happened is that you see that in the beginning it was drier in the farmer's field, and here there was some leaching, and here you see drying out, which gives some stress conditions, and later on again over irrigation. Well, what was the result? The result was this, that compared, well, we have two other treatments, deficit irrigation, not talking about that. The full irrigation and the farmer's irrigation. Full irrigation means full controlled by the sensors. We used a little less quantity of water, and the yield was a little higher. And you see here the difference in the, calculated surplus, calculated leaching or drainage. It was really successful. So yeah, in this case we had success. Either both we had a higher yield and we had less leaching. But in well-controlled systems, I can assure you that you will not gain yield in this way. Yeah, it's just not you cannot promise that you always have better yields when you are going to control your irrigation by sensors rather than your good feelings. So yeah, what is okay? You can say, well, this is a good way to go using sensors, but I have to warn you, there is some issues you have to consider, like for using sensors, you need specific calibration of each sensor, and in fact, each sensor in each location needs a calibration because soil is quite heterogeneous. The reproducibility is low, so if you put out a sensor and put it back on the same location, you never get the same result. So it's better to leave the sensors in the soils if possible. There's a very large variability among your field, and on top of that, by using sensors, it may be good for signaling irrigation, but you never can measure leaching. Yeah, you don't know if you leach out or not. For practical use, you need to establish your own set points for each sensor, and each location needs also its own reference points. And there are some technical issues as well with sensors, which I skip by now. Then we have another system that's what we have developed as a decision support system. It uses, next to sensors, also models. And the models determines you for the irrigation, fertigation. Well, you know, the crop needs water. It's for transpiration, it's for growth, and of course the soil itself evaporates. So we can model this total water demand. We call that evapotranspiration. Of course, you have to take into account how you have covered your soil by mulching, plastic mulching, or whatsoever, and what kind of crop you have and irrigation method. For the crop, well, the climate, the greenhouse climate is important, very, very important. Irradiation, the vapor pressure deficit inside and also outside, the temperature outside, heating system, well, and of course, parameters from the crop and the greenhouse itself. But all by all, you can calculate, because what is transpiration? In fact, it is the difference between the heat which you get from the sun and the loss of heat through the air back and what is consumed by the soil. Well, there are several methods. I skipped this one. This is the famous Penman-Monteith physical method to calculate the transpiration. It's a very complicated calculation, and you need, for instance, the Kc factor, which is the crop coefficient. Another alternative is to use the model designed by my colleague Cecilia Stangolini and some other colleagues from Italy and France. But you need, for this, the leaf area index. And the leaf area index is something you have to measure. So we came up with an alternative which is even more simple. Well, it looks complicated, but it isn't. It uses easy accessible data which you have already on your computer, on your greenhouse computer. And the only thing you need is a crop-specific factor. Well, we use this model, and this is just an example showing the very good relationship between the modeled and the measured transpiration of a tomato crop throughout the year. Okay, this is implemented into a system using also sensors. It's called the emission management system. Well, on top of that, or next to it, we also use the lysimeter, a simple, a simplified lysimeter. For those who are familiar with lysimeters, it's just a big container in the soil where you filled up with the same soil you have in your greenhouse, and finally you measure the quantity leached out. We have implemented these lysimeters into practice and use that for irrigation control, like here, some pictures. Okay, yeah, we put this in a project together with the growers, and we try to establish good data from the use of this emission management tool, and we disseminate it. And just to give you some results, in our situation, 3 types of growers. One type of grower we call the reactive grower. That's the one really wanted to increase let's say to decrease the leaching, tuned to fertigation to the demand of the crop, and are also aware about their responsibilities to the, let's say, the society. Then there is a group of growers we call the seeking grower. He's already on a good way, but still looking for improvement, is not very successful yet. But this group of growers, and this is really at the moment the largest group, is the indifferent grower. He wants to do no concessions on the irrigation or the fertigation, because he's afraid that his crop will be more heterogeneous. Well, this is let's say, representative of the first group, the reactive grower, organic grower, and he's in a good way. You see here, this is the accumulated irrigation, and it is the calculated evapotranspiration. You see there is a gap, but this gap is caused by this period here, where he changed from drip irrigation to sprinkler irrigation. Well, this is organic grower, so he need to do that. But in this phase where he used it, where the changeover was, there could be some improvement. So the next step could be that he increases this, decrease the gap. Well, skip this one of the time, but showing just that there are good results. But let me show you this result. And this is still bothering us because in the chrysanthemum crops, the gap between, in this case, accumulated irrigation and accumulated evapotranspiration is, you see, big. And this is then the calculated and also the measured leaching by the lysimeter. It's really big, this gap. So we are not there. This is another example, Astromeria also, but this grower is trying to learn, and here was some technical problem where he had, unfortunately, some leaching. Although he does his best, there is still at 12 till 18% leaching in that in our results. So if you look to a larger picture, then you can see that there is a decline in the irrigation surplus. So also a decline in the nitrogen leaching. However, we are not there. There's still some things to do. So in conclusion, that I can say that the water management in greenhouse, soil-grown greenhouse horticulture, that this is really a crucial factor for sustainable management. Of course, that's an open door. Water quality is very important. Yes, and irrigation management tuned to the crop demand. It's a possible way to go. Though you need tools, lysimeter or sensors or a model or a combination of these. Having these tools is also something. You can have these tools, but you have to use them. And this is something which is, well, it's not a joke, it's a realistic point that some growers do have these tools, but still they make the decisions on their own feeling. Yeah, so, and leaching can be under control, but there is a risk, and I have to say that, and I think in the audience here in Almeria, you are aware of that water, depending on the source you have, it can have a risk of salinity. So be aware, again, the first point or the second point, that water quality is of very, very high importance here. And I said it this morning already, that for the implementation of these measures, next to reduction of leaching and contribute to the sustainability, you need to add something for the grower that he really benefits from it. And what we always try to say, well, okay, you have full control over your greenhouse climate, so your whole crop management you have under control. You know everything, every bit of every moment, what's going on the temperature, on all levels in your crop, but you do not know anything about your soil because it's like a black box. But by using these tools, you also have control, or you start to having control also over this black box. And that's some things that persuades them to say, yeah, it's okay, this is something we can go for. I think this is my last slide, so later on maybe some questions.